Hello, everybody. This is Yanis Dokas, the moderator of session 9, entitled Recent Earthquakes in Turkey and Syria, Issues that are Arising. I'm very happy to be together with great experts in the field, with Konstantinos Nikas, with Fabio Sitella, and Vasilios Margaris, who will provide the talks of this session. We will start this session with Konstantinos Nikas with his presentation entitled Mission in Turkey 2023, Challenges and Lessons Learned. As many of you know already, recently we had a major earthquake in Turkey, mega earthquake, and Nikos, who is the structural engineer of the Greek Urban Search and Rescue Team of Greece, has participated there, and he will explain to us a little bit some aspect of his mission there and some issues that are important in terms of health and safety, and not only just about these aspects. A few words about Nikos. He's also a technical expert of the European Union Civil Protection Mechanism, and he is also Greece INSARG policy focal point, the Urban Search and Rescue Global Network under the United Nations umbrella. And with these roles, he also participated in several missions, urban search and rescue missions in several places, including Turkey, Ukrainian humanitarian crisis, Croatia earthquakes, and Nepal. So, Nikos, thank you very much for being with us today. We are ready to hear your presentation.
So, Mr. Dokas, thank you very much for the introduction, and I'm really happy to be here with you today. And I'm also very honored that you host me as a representative of the Hellenic Fire Corps, and also as a representative of the Special Disaster Management Unit, which the personnel of which took part in the recent Turkey earthquake. Just to begin with my presentation. My presentation is regarding the challenges and the lessons learned of the recent response of the Greek team to the Turkey earthquake. And to be honest, because there are too many things to be said about an urban search and rescue mission, and of course in every mission, I'm just going to try to give you a picture of the whole mission time frame, and also some things that have been majorly as concerns or are as problems during a disaster, and how we manage to tackle them in the field. So as you all know, in 6th of February current year, at 4:17 local time, a big earthquake with a magnitude of 7.8 struck Turkey, with an epicenter at around 35 kilometers west-northwest of Gaziantep, and a depth of 10 kilometers. From the first look of it, it had all the things that a disastrous earthquake has, all the elements. After some minutes, a second earthquake followed, a big aftershock of magnitude 6.7 at around 4:28. So you can imagine by those.
Yes. I do not know, Nikos, we lost his signal.
Yeah, can you hear me?
Yes, Nikos, we lost you for a moment there. So if you could please start several, can you repeat what you said 10 seconds before that, because we lose your power?
Yeah, of course. Yeah. And after this earthquake, after the first major earthquake, we had an aftershock 10 minutes after, at around a magnitude of 6.7. So you can imagine the released energy of this event. Also is really crucial, the time of the earthquake, because first of all, a lot of people were sleeping at this time, and also it took several hours for the Turkish authority to have a clear picture about the disaster, the magnitude of the disaster. So at around 6:22 local time, Turkey requested an international assistance, especially for urban search and rescue teams. Our team was monitoring the situation from the very first moment as we received information about this disastrous earthquake, and around 10:18 we began mobilizing procedures with close cooperation with the Hellenic Air Force. We managed to depart from Athens at around 15:53 local time, Greek time, and we deployed firstly with a rapid response team configuration which had 25 people. Of them there were 20 rescuers, 1 structural engineer, 4 medics and paramedics, 2 rescue dogs, 1 rescue vehicle. And this rapid response configuration was followed by 18 people and 1 rescue dog that arrived in Turkey 2 days after. So the full medium USAR configuration was complete. During this time, a second big earthquake, which by the magnitude of it, I really, as an engineer, cannot comment it as an aftershock. A big aftershock, let's say, of a magnitude 7.5 struck Turkey, followed in this case again after a couple of minutes by a second aftershock of magnitude of 6. So you can imagine, if you see the timeline, you can see that from the morning, from the early hours of the morning, during 1 o'clock local time, we had 4 really big earthquakes that struck in the same area of Turkey. The Greek team arrived at around 7 o'clock in the afternoon local time, and at the Incirlik military air base, which is 190 kilometers from the Hatay area, which was the main area that had the main disaster area. So as the international protocol says, we had to pass the custom procedures because Turkey is a non-EU country, and also we had to undertake the registration procedures as an international rescue team. As we arrived in Turkey, the Greek team, we were the first international team, along with the Swiss team, that we were on the site. So this by itself has many difficulties, because the first international team has to do a lot of things, and also to establish the reception and departure for all the national teams. So if I wanted to give you a clear picture, we arrived in the Incirlik airport, which was the main entry point of all the Turkish national help. We had medical staff from all around Turkey over there in the airport. We had NGOs, we had Turkish rescue teams, national NGO teams, we had army and police personnel, international teams, and also humanitarian aid. All these people and in-kind assistance was entering Turkey through Incirlik airport. So it took us many hours to find a way to go to the disaster area, because and as you can see by the timeline, Greek team had the opportunity to depart in Incirlik air base to go to the Hatay area at around 1 o'clock in the night. And the transportation was very, very difficult because the Turkish authorities had to make a triage of the needs and use all the available transportation data accordingly. So it was the transportation of the OSAR teams and also the transportation of the medical staff that arrived from all around Turkey was the first priority. But it was difficult for us to find the proper transportation for personnel and also equipment. Because I must say that the Greek urban search and rescue team, as all urban search and rescue teams, has special equipment that take a lot of transportation volume and needs special provisions. So we finally arrived at 6 o'clock in the morning to the disaster area. We did 6 hours. It took us 6 hours to make a 190 kilometers highway trip because the traffic was tremendous. There was real problems, and also there were real problems in the infrastructure from Adana and Titzirlik to the Struct area due to road damages, landslides, rock falls, and whatever you can imagine, really whatever. So we had to assess for the building of the base of operation because, as I said, we were the first team. The first base of operation proposed by the Turkish team didn't cover our standards and the international standards. So we made a new assessment because the base of operation, the base of operation must cover some standards regarding safety. We are in an earthquake area. We expect aftershocks. We expect geological hazards. And also we must be sure about the security of the place, enough space for the tents and for the parkings, not only for us, but also for all the incoming teams, the international incoming teams that they will follow. And of course, the base of operation must be close enough to the disaster area, but far enough, with balance, but far enough outside of the urban complex, so to be safe. We had to check also the mobile and radio signals for the designated base of operation. And a big trouble for us was that we didn't have a liaison officer on the site as we tried to find out the new base of operation, because as you can imagine, even AFAD, which is the civil protection of the Turkish authority, of the Turkish government, was really overwhelmed by the magnitude of this disaster. We are now at 24 hours after. So we managed to start to set up the base of operation. The base of operation must be fully functional before we are about to operate. And it must be fully functional because if we were not establishing the base of operation, then we cannot use our equipment, we cannot use the fuel, you cannot use our personal protective equipment and the rescue equipment. So the problem is that this time there was no international team other than us present in the site, limited security in the site of the base of operation, and great number of locals that were asking for help. They requesting for help. The help was about sheltering, was about food, was about urgent medical things, and we were, how can I say it, the first uniform guys that arrived close to the disaster. So you can imagine the mentality. They don't care if you are in the national team and you must follow a procedure. They will come to you and demand for your help, and it's very logical. So we had the problem to try to balance, to do our work correct and on time to be ready for operational cycle, and also to diffuse a little bit the pressure from the locals. So we try to to work a little bit flexible and outside the standards. We set up an information gathering point, gathering information from the locals about confirmed live victims, missing people, with spots on Google Maps, and we all with all their data like telephone names, etc., etc. This gave us two things. The first one, we gained time diffusing the locals' tension to establish our BU and build our base of operation, and also we obtained a very valuable set of information that was used by us in the beginning of operation, and that was also the first pool of information used by all the international search and rescue teams. Greek was our team deployed in the field at 10:42. I really don't want to bother you a lot about the operation, because the operation is very technical. But I want to say you one thing. I have a double role. I am a firefighter officer, and also I'm a civil engineer. I couldn't have imagined this scale of a disaster with both my roles. I couldn't have imagined that thing that we saw when we deployed over there. Totally, completely destruction of infrastructures, of buildings, dozens, not to say hundreds, of missing people, dozens live victims that were spotted on the fields. We hear them. They were asking for help, trapped. So I don't want to. It's very difficult for me to give you the overall picture. The Greek USAR operations circle lasted from the February 7 to February 12. 24 hours non-stopping during day, during time. In this time frame, we had the opportunity to succeed in 5 live rescues, 5 dead extrications, 2 sector assessments, and unfortunately multiple dead verifications. Most of the rescues were in a really confined space, which was a very real problem for us, because of the time of the earthquake, a lot of people were trapped in their bedrooms. Architectonically speaking, the bedroom is the smallest area of your house compared to the living room and other places, and also it's the area which has the too many furnitures and also too difficult materials for us, like mattresses, like beds, etc. So you can really you can take the feeling from the pictures, and also I have this small video as to show you how it was working in this kind of environment. This video was taken from the live rescue of a 20-year-old girl that took us 12 hours to succeed in it. It was 20 meters inside a totally collapsed inclined building, and we had to extricate her after she was trapped by a beam, and also by the bodies of her dead sister and her dead baby. So the operations, the other thing is that the operations were conducted under the constant presence of the locals, that there were not trained personnel like family members and neighbors that were very difficult to evacuate. Another problem we had is that the most search and rescues were carried out in partially collapsed buildings, because there you have the most the biggest opportunity to find living people. So it was a great risk for us and for the all team members, because I must say to you that we were constantly under aftershocks. We have 5.5 that found us inside the rubbles, and also a lot of above 4 that found us all over these areas. Of course, it was very, very difficult during the night because it was an extreme cold during those days, up to minus 10 degrees Celsius, that made our job really difficult and our lives really, really miserable. So the difficulties in the operation, I want to give you a sum of them and how we tackled it. So as I said to many victims, especially in the first 2 days, and many unconfirmed information, the large number of victims present in this kind of earthquake was due to the large scale of the disaster. So we had too many victims, and very difficult to confirm which of the information is valid and which is not. So we couldn't follow the normal procedure like assessment, prioritization, like triage, and then rescue. We had to adapt a little bit and adapt the approach first come, first serve. We found somebody, we extricated him, and then again and again and again. Until the international teams coordination center was established in day +3 of the disaster. So we had the opportunity to filter and delegate the information and the tasks. We had logistical problems, like in the first 2 days, we didn't have the ability for water using for shower and cleaning, and also lack of transportation and the lack of fuels. To be honest with you, we try to be also they are flexible. And try to develop to show the adaptivity skills needed in such kind of operation. We collaborate directly with other teams and the locals, and try to find our own solutions to this problem until AFAD and the Turkish government had the opportunity to walk again on their feet and give us the logistical needs, cover us. The language barrier was really a thing in the first 2 days before AFAD gave us the opportunity to use some translators, some volunteer translators, which did a great job. And also another thing about this area is that this area is not very English speaking, and also except of the Turkish, we have Arabic speaking population due to proximity with Syria. So again, we try to find local focal points by the people over there to help us voluntarily for the translation. Lastly, the presence of non-USAR trained personnel in the field. I told you about the locals that were on the field and they didn't want to leave, and also about the military personnel, the Turkish fire rescue personnel, which in several cases were incident commanders in the field. So they were not urban search and rescue trained. So if you are working and you are not trained in this kind of operation, you are liability to the operation and to the other team members because of the lack of knowledge of the proper safety and security procedures. So we adapt a little bit, and we had to take the lead sometimes, and also to take in our lead also the locals and the local non-USAR authorities. So to have a clear picture about the international response, I really tend to say that this kind of operation will be our career's major event. We had 219 international USAR teams from around the world, and you see in the map all the countries that send USAR team, not in-kind assistance, but only urban search and rescue teams. Approximately 11,000 personnel. many dogs that there are available tool and did a great job. For the dogs, it was even harder with those circumstances. That we are proud to say, as a global search and rescue community, we succeeded in 300 live rescues overall in Turkey. Of course, as an international community, we have made and we are under processing our lessons learned from the Turkey. It would be a great lesson for the INSARAG and UN community to adapt and to see. Some of them that have risen is connectivity issues in the field, like we didn't have the opportunity to have data or mobile phone, or it was really unstable. Different channels for deployment. Some teams were coming from AFAD, some from the Ministry of Foreign Affairs, the EU mechanism. So it's really good if you have established as an organization and as a country only one channel for deployment, one organization asking, one receiving. The briefing of the arriving international teams were not consistent because of the lack of personnel, and it's very logical, especially in the first days. And of course, the national response structure, as I told you, varied in different sectors. Like in some sectors were people leading by the civil protection of Turkey, others the military, the government, the police, or the local fire. So all these make it very valuable as a nation and as an organization to build resilience and also great national capacity, not to be able to offer help, but also to be able to receive and assist help. Just to give you an overlook with numbers, because numbers never lie, they don't give us the feeling, but they can give us the true picture. Those, unfortunately, are the casualties. We are talking about 5,500 deaths. And I always say, when you see a lot of zeros, there is always something missing. And the injured people. So about the infrastructures, you see that almost 160,000 buildings were heavily damaged, collapsed, or uninhabited, which of them we are talking about 500,000 unit houses. So you can imagine the sheltering problem arose from this disaster. And also 42 out of the 116 hospital buildings were totally destroyed. So we are talking about a complex and multiple disaster, and not overall to forget the people, because we tend to look at the numbers and the statistics, but we are talking about people. And all the numbers conclude in this. This disaster didn't, in my opinion, didn't have a great impact only in infrastructures and in buildings, etc., and economically, etc. But from my point of view, and as I witness working and living with them for over 1 week, it really breaks the social fabric of these areas, which will be very difficult to make them again strong and flourishing. So I want to thank you very much, and I would be very glad to hear and answer and discuss anything you want.
All right. Thank you, Konstantinos. Very interesting presentation. Indeed, the event, the earthquake in Turkey and Syria was, maybe one of the largest earthquakes that have been recorded in the recent history. But Vasilis Margaris will say a few things about that. Let me see questions. I cannot see anything at the chat as a question, so I can make a question. To what extent your training has helped you to adapt, to adapt in this situation? Because you mentioned in several occasions during your talk that you have to be a little bit soft in the procedures and to adapt in order to manage all these, people coming and all this data, the lack of coordination, all this kind of stuff. So my question to you is, are you taking such a training in your team, or it is just experience?
Yeah, it's very interesting question regarding the overall also theme of the GALA. And I must say this: all the technical skills, it's easy to obtain and trained and develop. All the soft skills that you refer to, like adaptivity, like flexibility, like the ability to adapt in different circumstances and in de-escalating, or escalating situations, it's something that comes with training, constant field training, and also experience. But there is one other thing from my point of view. It's the ability as an organization to set the procedures, to set the specifications in this way that somebody can be flexible around them. So from my point of view, the golden rule is between making a procedure that covers all different aspects of a disaster, but inside this procedure, let your people breathe and let the personal capacity develop. Because in disaster and also in risk assessment procedures, we try to cover all the different situations and all the different and make all these strict and very well organized procedures and organograms and flow diagrams, etc., etc. But from our point of view, as a fire corps, I can say to you that you can never predict all the steps of a disaster. You can never do that.
I totally agree with you, Konstantinos. So let the people, a little bit degrees of freedom, I would say, in order to assess their own the situation and, adapt, and in order to provide the best service that they can, given the situation, given the context of at the field. So thank you very much.
And
Yes.
Yanis, just one remark about this, about the people, because, and I think it's very applicable to the conversation. It's a nice way not to drown your people, and it's a nice way because all the organizations, the biggest investment is their people. It's a nice way to let them develop their skills, because we invest in them, so we want them to flourish in a disaster situation or in this kind of situation.
So at the chat, we have a couple of questions, but because the time has passed, I will allow you, Konstantinos, to reply at the chat to the question. Just want to say the note from Mark: true heroes attending with personal sacrifice in truly difficult conditions. So yes, I will totally agree with that. And then we'll have Emilia that sent another message. And then let's have all the discussion, the question, when we have time after the presentation of all the speakers. Thank you very much, Konstantinos. So we are moving to our next interesting presentation entitled "The Technologies Developed in Search and Rescue Project, the Role in Supporting Victims and First Responders Safety in Search and Rescue Operations." So now on the floor is Fabio Sighiela, Research Director at the Institute of Biomedical Research and Innovation of the National Research Council of Palermo. Fabio has has a background in environmental epidemiology, but has been involved in many projects related to search and rescue mission and the relevant technologies. So Fabio, please.
Good afternoon. Can you hear me?
Yes, very good.
Thank you, Professor Dokas, for your presentation, and good afternoon again to everybody. I'm really happy to be here, and thanks the organization for the kind invitation. I'll try to share my screen. Please let me know if you can see the first slide.
Yes, Fabio, we are able to see your slide.
Fantastic. So I am here to talk and present the technologies that were developed in the search and rescue project, and in particular the role of these technologies in supporting the victims, and not only victims' safety, but also first responders' safety in search and rescue operations. The search and rescue project is Horizon 2020 Secure Societies project, which started 3 years ago, and that was led by the National Technical University of Athens, and that will have the final conference the next week in Athens. Search and rescue project was aimed at designing and implementing and testing through a series of large-scale pilot scenarios a modular and high interoperable, mainly modular, open architecture platform for fast rescue. The project saw about 30 among partners and user organizations that participated in the project. The search and rescue project architecture was designed to integrate advanced hardware and software solutions to be adopted in disaster management system. This to cope the vision of the role played by the civil protection in Europe, which needs a common framework from a prompt assessing of needs and an effective and efficient integration of responses. And you will see how the integration is the main core of the project, the integration among all the technologies and components developed within the projects, which also aims to create advanced technological solution for guaranteeing the rescuer safety, as I said previously. To test the search and rescue platform with its technologies and components, 7 use cases were planned in real settings between April and December 2022. The first one use case was held in Poggioreale Old Town in Sicily, in the southern region of Mediterranean area of Italy, which was a particular exercise scenario. In fact, the Poggioreale Old Town was really destroyed by an earthquake of magnitude 6.4 in the night between January 14 and 15, 1968, the Belice earthquake. The city was abandoned and rebuilt in the next year downstream at a distance of about 3 kilometers, the new Poggioreale. The search and rescue use case 1 was named Victims Under Rubble and was designed by the National Research Council, my institution, in close collaboration with the Regional Department of Civil Protection and the Regional Direction of Fire Department of Sicily, and involved 133 participants. In the use case, casualties were simulated of people trapped under rubble or in premises not reachable because of an earthquake in 3 different scenarios. A nursing home for the elderly in which people was trapped at the first floor while the stairs was not useful. A collapsed parking lot and people under the rubble. In the use case 1, most of the technologies and the components tested within the project were tested. First of all, the emergency communication app, and then the strategic, operational, and tactical levels decision support system, along with the physiological decision support system. We will see what they are in the further slides. Smart textile professional uniform, along with its wearable strain sensor and wearable sensor for ECG and EMG recording, a wearable GPS tracker, a rescue system for especially designed for children and kids, and an artificial intelligence algorithm for recognizing objects from drone images. The Concord platform, developed by Connectable, one of the partners of the project, as I said, is the core of all the technology used and developed in search and rescue project. In fact, Concord is a cloud-based communication platform based on a user-friendly smartphone app that is able to share information among first rescuers present in the field and to send data to decision support system. Concord is especially dedicated to crisis management operation and is aimed at improving the search and rescue field operation by means of its features. In fact, all the technologies developed within search and rescue are completely integrated and adapted in Concord, so that they constitute a final platform enhanced with situational awareness and precise decision-making. Concord provides a lot of information for different actors, provides emergency medical services data, such as organization name, location, availability of the services, information on hospital data, such as trauma operating theaters, etc., information on victims' data, such as injury description, and then first responder data, and also data to the high commander's task, such as the incident details. In search and rescue project, two different decision support systems that act jointly, obviously, were developed. The first one is the strategic, operational, and tactical decision support system, SOT-DSS, which provides allocation of the available EMS unit to the incident, depending on the estimated needs. Allocation of patients to transport vehicles and first receiver, hospitals, based on given order of evacuation and triage result for present injuries. And allocation also of tasks to available actors on the field, given demand predefined by the field commander. Furthermore, SOT-DSS provides an estimation of the expected casualties and demanded resources, EMS units, given historical data on emergency incident recordings, so that the end users of the SOT-DSS are all the actors present in the field, starting from the high commander, the field commander, all the actors present, and also the information points for people and citizens. The other DSS service developed in search and rescue project was the Physio-DSS. That means physiological evolution of the victim decision support system. The Physio-DSS provides prediction in terms of the distribution of physiological status of the victims with the computation of the distribution of the expected time to death of each injured victim. And also automatic computation of relevant indices and scores for the assessment of the victim's impairment and triage, so that the Physio-DSS is able to provide a prioritization of the victims for the collection of victims and the call for the needed medical services. How is the physio-DSS implemented? It is composed of a set of functions and algorithms implemented in C++, and it is delivered at a web service that is located at this address that you can see in the slide. physio-DSS also supports an interoperable machine-to-machine interaction. The physio-DSS is able to follow the evolution of the physiological variables of each victim in terms of probability distribution for a victim which has an initial normal health condition. I mean, in terms of oxygen range, respiratory rate, state of consciousness. Not only the physio-DSS is able to define the condition of the victim at the beginning, but it is also able to follow the development, the changes in the health status of the victim using the information coming from the victim during the operation in the field. In the search and rescue project, a smart textile professional uniform was also designed and developed by University of Florence. This kind of uniform had wearable strain sensors and wearable ECG and EMG sensors embedded in it to follow the physiological function of the first rescuers. And also a wearable GPS tracker was developed. Look at this component each by one. The smart protective uniform for the first responders, as I said, is provided with several embedded monitoring sensors connected to a dedicated smartphone. In the same smartphone, a GPS tracker is active, allowing the real-time monitoring of the position of the first responder on the scene. ECG electrodes for electrocardiogram are embedded in the t-shirt and the underwear. EMG electromyogram electrodes and strain sensors for joint angles estimation are embedded in the leggings. In this slide, you can see on the left the underwear. Then in the central picture, you can see the uniform. And on the right, you can see the electrodes down and the strain sensor in the upper picture embedded in the leggings. In the picture in the middle, in the upper panel, you can see an electrocardiogram, ECG tracing derived from the sensors on the field, allowing to know the heart rate and the cardiac function of the first rescuer. The EMG takes the electric signal from leg muscles and indicates the effort. Continuously indicators in real time the effort developed from the first rescue during the exercise. In the lower panel, you can see the position of the electrodes for the electromyogram in the t-shirt and the electrodes for the electromyogram and the strain sensors in the leggings of the uniform. The rescue children system for children was also developed by University of Florence to provide first rescuers with advice able to protect injured babies and kids during rescue and transport. You can see in the left panel, in the left picture, the system during a demonstration, and in the center picture and in the picture on the right, the device during its use in on-field operation. And finally, the artificial intelligence algorithm for recognizing objects from drone images. And these algorithms were developed by IDS, another partner of the projects, and aim to detect humans as objects from drone images provided in field operation. The algorithms provide boundary boxes, as you can see in the pictures, with the detected people and a probability number with the accuracy of the detection. As you can see in the picture down on the left, on the right, sorry, you can see that also in very bad light condition, this is the church of the old town of Poggioreale, the algorithm is able to identify victims here in the darkness. Finally, the conclusion. The aims of the technologies and components that were developed within the search and rescue project are aimed at a faster location of victims, to a more objective prioritization of victims based on actual resource availability, and finally, to protect the safety of the first responder. Thank you for your attention.
Thank you very much for your presentation, Fabio. Indeed, there are many technologies that can be integrated in order to provide a better, not only situation awareness, but also some aspect about the safety of the people at the field during emergencies. And a short question to you, to what extent you think that this technology have reached the maturity in order to be actively used in search and rescue mission? How much work we need to do in order to make them from prototype into a fully functional system?
Oh, okay, yes. I could see that there was, I show you the information coming from the use case 1. We had 7 use cases, and the improvement of the technology and the stability of the technology was really sensible during the process. And we are talking about a time between April and December. I think that this technology is mature, and because it is based on a really user-friendly, I am not a fast rescuer at all, but the technology is very user-friendly. It's only dependent on the capability to use an app on a cellular phone, and it is very easy to be used. And at this time of development is, I think that is very stable and almost ready for be used in real operation.
All right, thank you very much, Fabio. So if you want to ask questions to Fabio and to the rest of the speakers, please write your question in the chat, and the speakers will reply back to you. And if we have time at the end of the presentation, we will have a chance to discuss further. So let's move to the next speaker, Vasilios Margaris, who is also well known to me. Vasilis, nice to see you again. So his talk is on stroke earthquakes and infrastructure, prevention and reaction. Vasilis Margaris is a graduate in geology, geophysics at Aristotle University of Thessaloniki, and he has scientific publication, many scientific publications on seismology and seismic, and he's a very good colleague of mine. They're one research project that we are running here in our university at Mokos University of Thrace. So, Vasilis, please.
Thank you very much, Professor Dokas, dear Yannis. Please let me share my screen. Okay, and now okay. Dear colleagues, dear attendees of this very interesting Safety GALA virtual workshop 2023. At the beginning, I would like to thank you, the organizing committee, and also chairperson and moderator, Professor Ioannis Dokas. And in a few words, I would like to, as a simple introduction, I would like to present you some items of this very strong earthquakes, mega earthquakes, as Professor Dokas mentioned before, the infrastructures in Turkey in 2023. And a basic question for this is what is the more useful for us, to prevention or to react after the earthquake? Both items, both subjects are very interesting, and I will try to discuss with you, giving some information about the strong earthquakes and also for infrastructures in Turkey 2023. Based on this earthquake and the seismic this seismic sequence and its consequences on the main critical infrastructure, the seismic prevention and the preparedness of the aftershock reaction will be examined, as I told you, as the most appropriate solution. So, looking at in the first transparency on February 6, 2023, a moment magnitude 7.8, let's say 7.7 up to 7.8, it depends of the different seismological bureaus, occur in the Eastern Anatolian Fault. Eastern Anatolian Fault located in this area in the southern east part of Turkey. And as the Disaster and Emergency Management Presidency Bureau gave us a very valuable and reliable information, seismological and strong motion data. The epicenter is located here for the main shock, and in this place we have the main aftershock, or the second strong event. Following this event, after I think nine hours, we have a second event with magnitude 7.6 up to 7.7. The epicenter is located, the first one close to Gaziantep city, and the second close to the Kahramanmaras city and the district. On the left, we can see some seismological information. On the right, we can see a simplified map of the studied area. Well, the two focal mechanisms of these two events are depicted with magnitude 7.7 up to 7.8, and the 7.5 up to 7.6 for the main aftershock. Also, in the same figure, we can see with the gray fault mechanism, an earthquake occurred in Doyan-Yol Sivirce. Sorry for my Turkish pronunciation; is very terrible, is horrible. 6.7. But I give you this information in order to tell you about the activity, the seismic activity in this area. In the right figures, also you can see some cross sections with the distribution of the aftershocks, with the main shock and the main event also here. And the two aftershocks, the two cross sections is along this line, A up to AA, and the other one is along the BB with the second event. We can say, and the after seismic first results, we can say that we have two different seismic faults activated during the first one, with the big one earthquake, 7.8, and the second one activate as a parallel, let's say, fault system. In the third transparency, we can I'll try to present you some information about the catastrophe and the devastating areas, but I think Mr. Nikas gave you some more updated information. I can tell you that according to the Ministry of Interior Disaster and Emergency Management Bureau, we have a lot of people injured, and also a lot of people lost their lives. And we have a very huge catastrophe in 10 different districts, as you can see in this figure. Quite important to see is the estimated affected population in the area, and also a larger map in Turkey. So we have an idea about the magnitude of the catastrophe, and also the consequences on the human beings. In this transparency, I'll try to give you some seismotectonic information about the area. The area is located along the East Anatolian Fault, one of the two main fault systems in Turkey. The first one is the North Anatolian Fault, and the second one is the East Anatolian Fault, where a very strong earthquakes have occurred in the past, starting with Gendiz with magnitude 7.2, Izmit in 1999, very well known in the area of Greece, with and also in Duce with magnitude 7.4 and 7.1. In Galdiran 7.5, and also in Van 7.2. We can observe that in this area we have a lot of earthquakes, but not very catastrophic, very strong earthquake, higher than 7 in our region. In the next map, a clear colorful figure of the seismotectonic in Turkey, recording also the main movements, tectonic movements between Arabian plate and Anatolian microplate, also the African convergences just under the Aegean microplates, give us an idea about the complexity of the seismotectonic of the area. Our region is here, as I told you before. Now, in this transparency, collected images, videos, numerous seismological data, such as the fault lines you can see in figure A, or surface rupture, as you can see on this topographic map, or space distribution of the peak ground acceleration and peak ground velocity, very important parameters for determination of the stronger ground motion. And finally, the spatial distribution of the moment magnitude, which have been recorded by the seismological stations in the area of Turkey or in the adjacent areas. In the next transparency, you can see some seismic rupture taken from satellites. So in the location of the strong in this area, you can see that satellite photos are downloaded from Maxar, showing surface rupture and estimated displacements associated with the first event, 7.8, between Torkoglu and Islahiye. You can see also the situation before and after earthquake, and also in these figures. It's quite important because with all these marks, we can have an idea with the permanent displacement or maybe the deformations close to the epicentral area. In figure B, all these insets, we can give us some very useful information. Let's say in figure B, in the upper in this photo in the upper part, some fissures on the epicentral area can be observed in this photo, and in this one we can see some offsetting of the road around 2 or up to 4 meters offset have been observed in close to Güzelüert and Pazarcık cities. Down in the down photos, we can see 6.7 fence offset of along the main aftershock in Turkey during the earthquake with magnitude 7.6. And the last one is from the mission of the engineers from Technical Chamber of Greece a month ago. And this is the professor Basil Marinos from Technical University of Athens, engineering seismologist, and shows us the deformation of the railroad track caused by the surface fault rupture in Pazarcık earthquake with magnitude 7.8. Going a little bit further, I will try to give you an idea about the strong ground motion, very useful for us in order to design and then to give some suitable seismic input motion to the engineers. The locations of the strong motion in Turkey is shown in the upper left figure. The recordings, the station's metadata are disseminated through a FADS website soon and just after the earthquake. Is quite important because the Turkey strong motion network is one of the most populated network in all over Europe. Taking into account the extent of the Turkey and also the number of the instruments. The reconnaissance team downloaded the raw strong motion data immediately after they were available. It's clear that the recordings are currently evaluated by a FAD, and improvement the data quality are expected in the near future with much more qualified the data. Following visual quality control and data processing, 250 and 240 recordings are available after the main and after the main aftershock in the area. Also, in the same figure, you can see in the down left figure the distribution, the spatial distribution of the epicenter up to 200 kilometers far away from the rupture surface. And also you can see the main shock with an asterisk and the main aftershock with also asterisk useful in order to have an idea with the distribution of the recordings from this area. On the right, there is a comparison of the distance strong ground motion from peak ground acceleration, main parameter, as I told you, attenuation for various ground motion predictive equations. It's very useful for seismic hazard analysis. So for different empirical ground motion predictive equations, we plot also the data over there with plus minus 1 standard deviation. And we can see that the data follows and they agree with the predicted, with the empirical relations have been extracted with the previous data. So this is something very promising for us in order to use these empirical predictive relations in our analysis. Now, in this slide, I'll try to give you an idea about the seismic soil liquefaction manifestations in form of ejecta lateral spreadings. Also, you can see in these places, and also subsidence were observed as displayed in this figure. Some of these manifestations were observed very close to the building, to residential buildings, especially why? Because we have a kind of foundation poor performance. It's quite important also for this area. People who have been there for surveying or for inspections recognized some very crucial cases like that. On the right, the liquefaction phenomena were widely observed in Hatay Pasakio region, also in Hatay Iskenderun region, and in many other places. Now, concerning deep excavation, retaining walls, rock falls and tunnels, we can say that we have a good behavior just after the earthquake. The performance, let's say, of the deep excavation systems on the route was also investigated. And in Osmaniye Bashe underpass, which was supported by reinforced concrete cantilevers pile elements, no significant deformation were observed in the deep excavation support system. Of course, in some cases, we have some more damage. Rockfalls, for rockfalls, also we can observe some rockfalls in the benches of highways, and some examples are shown in these photos close to the road. For tunnel structures, we have some information about one specific tunnel in Erkenek tunnel lining, with a very minor, let's say, up to the medium damage in this tunnel system. Now about the landslides. One of the big landslides observed this. We have some kind of information from satellite. So so we can say that after February, I think 14th, 2023, an astronaut abroad in the International Space Station took photographs of a landslide in a canyon. Here we can see this or this, very close to Isla Hanet. And this kind of landslides were observed in different places in the huge epicenter area, almost 500 kilometers of epicentral area were covered all the East Anatolian fault zone. So now going to the next slides with the damage to shelter and housing. The earthquake impact on the shelter and the housing has been devastating in the most of the affected area, with very high levels and damage to the dense residential areas, hosting both Turkish citizens as well as Syrian refugees and asylum seekers. Several cities, notably Iskenderun, Atakia, and so on, have heavily suffered destruction. Several key UNESCO World Heritage sites, also we can see here one of them, were damaged, including Gaziantep Castle, Diyarbakir Castle, and many others. So just before close this this not so familiar for me because I'm not civil engineer, I'm geophysicist and engineering seismologist. The damage to the key infrastructure, most of damage have been sustained by the road networks, with limited impact to the other key transport infrastructures such as airports and railways. Main airports in the affected area have closed for civilian routes, but are operational for 8 flights or relief. So Malatya, Adana, Diyarbakir, Adiyaman, and so on are open for 8 flights. Also, similarly, real-world communications are functional during this time, but some of them have been destroyed, as I showed you, show you in the previous slide. In the left, we can see some landslides, crack and surface cracks on the road near Kartal and Yarbasi. On the right, you can see some landslides or rockfalls along the roads near Gaziantep, causing disruption in the service. And finally, we can see some landslides and crack damages on the road next to a water canal close to the Karhaman Maras city. Just before closing, I would like to give you an idea about the research and the knowledge that there exists in the area of Turkey, because our colleagues, the Turkish engineers and engineering seismologists, they have a very good knowledge about the seismotectonic regime and the consequences in their codes. So, Professor Gülerce from Middle East Technical University in Ankara in 2018 published a very interesting research calculating probabilistic seismic hazard analysis along the East Anatolian Fault, a work published in a very huge, a very famous journal in the United States. I show you some kind of some cracks in the area that they have studied, and also you can see in this place some kind of sketch, some kind of let's say simplified tectonic scheme describing the East Anatolian Fault, and also the East Anatolian Fault and the slip rates that they have calculated in order to use them for seismic hazard analysis. And on the right, you can see a rupture system and the instrumental seismicity with earthquake magnitudes greater than 4. The buffer zone used for source to epicenter matching are shown around the rupture systems. Small boxes show the earthquake associated with the rupture systems, whereas all seismicity used for calculations the seismicity parameters. So based on this information, Professor Gülerce and her colleagues, they calculated the expected strong ground motions in the area of East Anatolian Fault and proposed probabilistic seismic hazard maps for peak ground acceleration for different return periods, very crucial for the engineers in order to design a seismic construction. And we can see that the values for the two return periods, 450 and 2,500 return periods, and for different geological conditions, for stiff soil and for very hard soil, you can see that we have a range of peak ground accelerations up to 0.8 of G, or maybe 1.25 of G for these areas. Very, very huge values we can say. But in the next figure, we can see the observed values and also the observed peak ground accelerations in this area for the main shock and from the main aftershock. So the comparisons of the peak values are pretty good. The agreement is remarkable. And so we can say that using all this information, using all this analysis, and taking into account this in our designs, decision makers and engineers can use all this information in order to design a seismic construction and a seismic infrastructure, avoiding all this kind of disaster, all this kind of damage, and saving loss of life. So, as a conclusion, I would like to say prevention is much better than the aftershock reaction. We need to have reaction facilities, as Mr. Nikas told us in the first presentation, because we will have also damages, but we can reduce this kind of damages doing some actions. We can separate these actions into different categories. One is the priority recommendations, 1 to 4, and the other one is a second order priority recommendations from 5 up to 6. And we can summarize saying this: as a priority 1, establish an independent state seismic safety board of commission. As number 2, implement a risk reduction plan for critical public facilities, retrofit of high risk buildings, and 4, protect the transportation infrastructure. Quite important, because I said again, Mr. Nikas, transportation is quite important for the after the earthquake, the reaction, and to face all these problems and all this damage. As a recommendation for design, we can say to accelerate earthquake hazard assessment, geological mapping, faulting systems, and also to use all of them in our studies, develop incentives of increasing seismic safety, expand public education program with emphasis on self-sufficiency, enhance also the seismographic and also strong motion networks, and finally establish an earthquake information clearinghouse. And with this, and with the main conclusion, prevention much better than reaction. Thank you very much for your attention.
All right, thank you, Mr. Margaris. Very interesting information you provided to us, and also the relation between, the seismic analysis and what the researchers who are investigating the seismic phenomenon, how much their results actually can help us be resilient in such mega natural events. We are at time. But I will ask you one small question, Vasilis.
Yes.
Based on what you described to us previously, we can see that the scientists have actually, let's say, identified the red zones. All right, and you suggested some actions that we can take based on that. At the same time, at the beginning, I heard what Konstantinos said, that 119 hospitals were destroyed, whereas in your presentation, you said that some major infrastructure were intact, and the main let's say, infrastructure that were hidden by the event were the roads. The thing that I'm understanding is some infrastructure were designed in a manner that actually, to absorb the shock, whereas other infrastructure were not designed with this philosophy in mind. So, where do you see? How do you see these data from the seismologists, and not only from the seismologists, from the many scientists that involved in this resilience behavior of our societies? What has happened? Why we have 119 hospitals, collapsed, whereas tunnels and some railroads and some other infrastructure were intact?
This is a very good question, Yanni, and of course we can say that we can make a very, very huge discussion about this, but actually I need also a civil engineer with me in order to give an integrated answer. I can say this with my experience, almost 42 years experience working with civil engineers in the area of Greece and abroad. I can say that actually we need the engineering seismological knowledge, and also the geotechnical knowledge, and also the structural knowledge in order to have an integrated decision how can we study these prone earthquake areas? What can I say? Why I can say this? Because in areas like Turkey, as that we have specific and well defined fault zones, as the East Anatolian fault zone or the North Anatolian fault zone, very close to us, approaching also the central Aegean area. We can say that we need the seismological and also the geological and then the geotechnical knowledge in order to construct kind of buildings and not only infrastructures, hospitals, tunnels, and so on, but also residential buildings. And this is the explanation why in some places, in some blocks, residential blocks, some of them were destroyed completely, and some were no. The main intention for the designers and the decision makers is to construct for this kind of devastating earthquakes buildings well constructed, avoiding to collapse completely, and to construct buildings in order to be in a functional form and allowing the people to go out just after the earthquake. And the second one is to protect also the fortune of the people, not destroying and not having this kind of extended damage in all area. A lot of billions of dollars we will need to repair and also to reconstruct this devastating area. So this is a kind of, let's say, not a scientific answer, but this is a kind of recommendation for decision makers and also for the last as a last conclusion to the politicians. You can understand, you heard a lot of things concerning the buildings in this place, in this specific area, why they have very huge damages, especially in the tall buildings. Thank you, Yanni.
All right. Thank you very much, everybody. There are some questions that you can answer at the chat. Unfortunately, our time has come to the end, and actually we extended for 5 minutes. So I would like to thank Fabio. I would like to thank Konstantinos and Vasilis for their time in presenting their interesting work. So from me and my colleagues here at the panel, we would like to say to everybody a good afternoon and a good day. So thank you very much.
Thank you
very much.
Thank you very much.
Thank you very much.
Thank you.
Thank you
Bye
very
now.
much.
Thank you.